Hey, hello guys, welcome to this teaching segment. I'm about to just guide you through ways of formulating mathematical models in operations research. And as you know, operations research is a field of study that deals majorly with model building. We use the idea of linear programming to make mathematical models that are used in providing guidelines to manage and make decisions. And such decisions will lead us in the direction of the best feasible solution for an operation that is about to be undertaken. Now I have a question before me, and I want us to treat this together. This question says, Bellevue Inc. Marketing Department must choose hard to reach 2.7 million people. They seek to minimize cost for this operation. So how do we go about this? If you have this kind of question before you, and while you are solving that, you're about to provide a quality linear programming for it, I will advise that you take 4 simple steps that will help you to arrive at your formulation very easily. The first step says identify the main decision variables. Now we have data that are being supplied to us that we are going to work on. These are the hearts that are the sample data that has been provided that we're going to work on. So, but before we go into this, you have to identify the main decision variable of the data that has been provided. Then the next thing is to identify the objective function of the operation you're about to undertake. And after that, you identify what are the constraints that will possibly limit the operations or try to stand in the way as a kind of barrier. Then other stuff you need to also engage, you state other decision sub-variables that will eventually help you to put all your data together and arrive at a very good draft. So just like I said, I have this data supplied. We have the ads type, we have the audience size, we have the cost per spot, and we have the maximum number of ads here. Now in this place, if I have to look at what I've been provided with, I have, for me to identify the decision variables. Now, these are the 4 items on the list that we are about to minimize cost for. Now, if we want to take this operation through TV, through radio, through mail, through newspaper, how do we formulate a linear programming that will help us to achieve an overall cost decision variables, which I'm going to state out in this order. First step, the main decision variable. I have, for these decision variables, I have X1 will stand for the TV, X2 for radio, X3 for mail, X4 for newspaper. So having done that, I've been able to really state out the main decision variables. So the next step I'm going to take now is to identify the objective function. So what is my objective function? The overall objective function in this question is to minimize cost. So I go for that, and I said, for the objective function, I have minimize Z, and for us to minimize Z, we go to the cost of each of the variable we're given. So I have 550 X1 plus 230 X2 plus 300 X3 plus 150 for X4. So with that, I've been able to clearly state out my objective function that will help to minimize cost for the operation. So after that, we need to identify the constraints, and I state that out as Now for the constraint, I'm going to I have the number of possible ads for TV, radio, mail, and newspaper. So I'm going to state that out as X1 will be equal to or lesser than 30. X2 must be equal to or lesser than 20. X3 must be equal to or lesser than 15. And X4 must be equal to or lesser than 25. So with that, I've been able to state out the possible constraints for the operations. So the last step we're going to take here, after the constraint, we're going to move to state other decisions of variables, and that I'm going to focus on the audience size. The audience size that has been projected for the operation. So what I'm going to have now is for 4, we have $100,000 X1 plus 50,000 for X2 plus 45,000 for X3 multiplied by X3, then plus 37,000 X4, which all must be either equal or greater to 2.7 million. So I write to 2,700,000, and this signify the possible projection for the audience size. So after then, the last step we take is just to identify the non-negativity constraint, that which says X1, X2, X3, X4 must all be greater or equal to 0, and this one stands for the non-negativity constraint. And with this, you will have been able to successfully formulate a mathematical model that will help us solve this question very accurately. More of the way teachings on this area. I'm still going to bring more of them up. I want you to subscribe to my channel, and you'll still get more of these videos as time goes on. Thank you very much for watching. Thank you. Bye.